Okay, guys, today we're talking about sequences. There are two types of sequences, arithmetic and geometric. We're talking about arithmetic today. Okay, the question in the room was, what is a sequence? Leo said a sequence is a pattern, and that is correct. And while we were talking about patterns, we said, what are these shapes? Good morning. What kind of pattern do you see with these shapes? And Justin and Alexa said they're gaining a side. So a triangle to a square to a pentagon to a hexagon, and the next would be a heptagon with 7 sides. All right, so that's with shapes. Now let's look at numbers. Okay, so sequence is a set of numbers, symbols, or terms arranged in a particular order. Okay, so if you wanted the technical definition, here's the technical definition. So look at these numbers. 2, 4, 6, 8. What do you notice?
They're adding 2.
They're add. Oh my gosh, they are adding by 2. Oh my goodness. What? No, I'm not. Stop. You're ruining my recording again. So what do you notice? Yes, they're adding by 2. So what would the next term be? 10. Woohoo! LOL. All right. So here's a
coffee followed by a
no. No. All right. So actually write this down. So there's the two types of sequences. Like I said, today we're doing arithmetic. This is a sequence where the consecutive terms, consecutive means the term right after the other, have a common difference. So for example, the one we just did, the common difference was 2. They were going by 2s. Okay. Arithmetic would either be addition or subtraction. If you're just now joining, you're like, that says arithmetic. Yes, but I just pronounced it arithmetic. I don't need commentary. So arithmetic is a sequence where the consecutive terms have a common difference. So they're either adding or subtracting by the same factor every time. A geometric sequence is where the sequence or the consecutive terms have a common ratio. This means it's multiplying by the same thing every single time. So if you kind of think about this, arithmetic is linear. Linear. When we did linear functions, we were adding or subtracting by the same constant rate of change. Geometric, if I'm multiplying by the same thing, what is that? What unit did we literally just get off of? Nope, right after that one. Where I'm multiplying by the same thing, exponentials. Okay, so geometric is actually exponentials because I'm multiplying by the same factor every time to get to the next term. All right, may I move off this slide? Was that a no? Oh, okay. Okay. So what we're gonna do is we're gonna look at certain terms in an arithmetic sequence and try to figure out the pattern, okay? Now it's gonna get a little bit more difficult than this. So if you're kind of tuning out because you're like, oh, this is easy, just hold on, please, okay? So this is just like the one that we just did, 2, 4, 6, 8, 10, 12, blah, blah, blah. The common difference between the two consecutive terms is 2. It's going by a constant rate of 2. It's increasing by a constant amount of 2. Does that make sense? Okay. what we need to understand is terminology. So when I say the first term in the sequence, I'm talking about the first term in the sequence. The first term listed. The second term would be the second one listed. The third term would be the third one listed. And the fourth one would be the fourth one listed, okay? So let's look at these patterns. Let's see if we can figure out what it's going by. 1, 3, 5, 7, 9.
11.
And what's the description? Awesome. All right. Well, Alexa got that one. So someone's got to do the next one. 2, 7, 12, 17, 22. 27. Okay. And what's happening? Adding by fives. All right. Let's see. Another person speak up. Negative 16, negative 12, negative 8, negative 4, 0, 4, 8. What's happening? Adding 4. Awesome. And then this last one, negative 2, negative 5, negative 8, negative 11. And what's doing it? Perfect. So all of these, beautiful. Thank you for everyone who participated. What you notice about all these patterns that make them similar, they're either adding or subtracting by a constant term. So Ms. Patterson, I'm confused. What makes this difficult? What makes this difficult is there's two types of equations that you'll need to remember. So go ahead and title part of your notes, recursive notation. Recursive notation. Recursive notation. Recursive notation. Recursive notation. What is recursive notation? Recursive notation is when you're given one number in the sequence, you would use recursive notation to find the next term in the sequence. So we use the recursive notation equation to find the next term in the sequence. So for the fact of knowing the equation, go ahead and write this recursive notation equation down. AN equals AN minus 1 plus D. AN equals AN minus 1 plus D. AN equals AN minus 1 plus D. N, the letter N represents the sequence number, the number in the sequence. So for example, if I had 2, 4, 6, 8, 10, blah, 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 2 is the first number in the sequence, 4 is the second number in the sequence, 3 is the sixth number in the sequence, 4 is 8 number in the sequence, 5 is 10 is the fifth number in the sequence. So this is the, figure out the term before your next one. Okay, it's the term number. Okay, which part of the sequence it is in. So for example, if I was like, well, what would the sixth term in the sequence be? What the question was like, what is the sixth term in the sequence? What is the sixth term in the sequence? Obviously you can just look at it and be like, well, 12 is the next term in the sequence. But what you're going to be tested on is the actual equation. So for N, I would replace N with 6. So A6 equals A N minus 1, 6 minus 1, plus D. Well, let's see what they all what D represents. D represents the common difference. D represents the common difference. Well, in this example that I wrote, what's the common difference? What is it going by? 2's, right? It's adding by 2's. So here, that's what would represent the common difference, plus 2. AN minus 1 represents the term before. Oh, okay. Yeah, term before AN. The term before AN. Yes, perfect. So here, for this example, A6 minus 1, it'll be A6 equals, well, 6 minus 1 is 5, A5 plus 2, A5, just like Leo just said, the fifth term in the sequence is 10. So A6 would equal 10 plus 2, which would just equal 12. So what is this saying? This is saying the sixth term in the sequence is 12. Again, the hard part is not figuring out the next term. That's easy. You just follow the pattern. What the hard part's going to be is recognizing the equation. But it's pretty simple. It makes sense. It's saying the term before plus whatever that common difference is will give you the next term. So what do you need to know? You need to know this equation and that this is recursive notation. So if you didn't annotate the equation, go ahead and do that now. So write down what these terminologies mean so you can refer back to them in the future. All right. Our goal is to finish in the next 6 minutes. We can do this. Justin, if you need some tissues, there's some in the back of the room. So AN stands for the next term in the sequence. AN minus 1 stands for the term before AN, and D represents the common difference.
Will it always give you the list of numbers, or will it just be like N is this and that?
Good question. Yeah, it has to give you a list of numbers. There's no way to figure out the common difference without the list of numbers. Unless it gave you the common difference, like you just said. I think I've always seen it where it gives us the list of numbers. Great question, Alexa. So let's look at this equation. Let's look at this sequences. 2, 5, 8, 11, 14. What is the sixth term in the sequence? I don't want you to actually tell me the sixth term in the sequence. What I want you to do is go ahead and write what the equation would look like. So using AN equals AN minus 1 plus D. Everyone figure out A, what the common difference is, and B, what would the equation look like? Again, I don't want you to actually find the sixth term. I want you to just write the equation. Anyone feel like they got it? Anyone? Anyone? Feel like they got it?
Can I try?
Absolutely, please do.
So I put 14 in equals 17 in minus 1 plus 3.
Okay, cool. But instead of me actually putting the numbers, what I want first is to write out what the thing is. So A6 equals A6 minus 1 plus D. I mean, not plus D, plus what? What was it? Plus 3? Because the common difference was it's adding by 3s. And then what I'm looking, this is how it's going to look on the test. A6 equals A5 plus 3. So this is what I'm looking for. But perfect, Jaden, you just filled in everything, which is fine. You knew what, at least you knew what it was saying. But this is how it will look on the actual test when it asks for the equation.
So then the N is the term?
N is the term number.
Okay.
Okay, so that's what I plugged in for N, is the term number. Okay? Which Jaden just told us that the answer would be 17. Because A6 equals, well, A5 is 14 plus 3 would equal 17. So A6 will equal 17. Okay, here's another type of question you'll get. So this is going to get increasingly harder. So if you're like in La La Land, let's get back in earth here. It was just, the last slide was just telling everything we just said. A sequence can be generated by using AN equals AN minus 1 minus 5, where A1 equals 4. What are the first 4 terms in the sequence? Well, let's break this down. AN equals AN minus 1 minus 5. What does this minus 5 represent? The common difference. Yes, Noah, what it's going down by. So this is my common difference. This means I'm subtracting by 5 every time. So if the first term in my sequence is 4, how would I figure out the next term? Subtract by 5, minus 5. So that'll give me. And then what do I do to get the next one? And what would that be? And then how do I get the next one? And that would be? All right, there's your first 4 terms in the sequence. This is what you'll be tested on. This is what you'll be tested on. Please ask a question if you're not understanding. Ask a question if you're not understanding. Yep, you will get plenty today. LOL. Okay, this is just explaining what we just said. Okay, last one is explicit notation. Explicit notation. So what we just did was recursive notation. That gave us the next term in the sequence. Explicit notation is not, it gives us any term in the sequence. Explicit notation, you would use explicit notation to find any term in the sequence. You would use explicit notation to find any term in the sequence. Any term in the sequence. And hopefully what you notice is just the same thing as a linear equation, slope and y-intercept. That is literally what this is. Given the first term in the sequence, you would use explicit notation to find any term in the sequence. Any term in the sequence. Any term. The 5th term, the 500th term, the 5,000th term. Any term in the sequence. Mm-hmm. Can I go get you some tissue?
I can get you some.
Oh, Jaden will get you some. I was gonna get out there. Thanks, Jaden. The sniffles are for real today. There's no more?
This is the last.
Okay. I'll ask the front office for another box. Okay, so the equation is AN equals A1 plus D times N minus 1. Where AN represents whatever term we're looking for. A1 represents the first term. D represents the common difference still. And N still represents whatever term we're looking for, term number. We're almost done, guys. Almost done. Almost done.
What was the first one?
Hmm.
First A.
It's just whatever the value is for that term number. Yeah. So. Beautiful. All right, so we're gonna write the explicit notation equation for this sequence. This is the same one we did earlier. So 2, 5, 8, 11, 14. What's the common difference? Plus 3. So this is adding by 3. What is the first term? 2. So writing my equation, AN equals A1 plus D times N minus 1. Writing my equation, it would be AN equals, well, the first term in the sequence is 2, plus the common difference is 3. So 3 times N minus 1. And this is all I'm looking for. Now, some of you are like, wait a minute, am I gonna have to memorize these formulas? Are these on the formula chart? These are not on the formula chart. At least I don't think so. I'm pretty sure they're not on the formula chart. The big thing here is on these questions, guys, it's you just have to remember, this is like slope and y-intercept. 2 represents your y-intercept because that's your first term, right? And technically 3 represent your slope because that's what your what your rate of change, what it's going by each time. So this would kind of look at your slope. So you don't really have to memorize this because it's basically what we've already done earlier on in the year. Oh, well, hold on. Let's find the let's go ahead and find. I'm not really sure why that ended. I think this was supposed to be a near pod actually. Anyways, let's go ahead and find, using this equation, let's find the 99th term. I know, so hard. Okay. So I'm looking for the 99th term. So I'm looking for A of 99. So that would equal 2 plus 3 times 99 minus 1. How would I go about solving this? Yeah, you could put it 2 plus 3 times 99 minus 1. Yeah, you could put that in Desmos. But for the sake of the fact that I think we can do this by hand, I'm going to do it by hand. I'm going to first do the parentheses. 99 minus 1 is 98. And then distribute. So 3 times 98. I don't know what that is.
Wait, what? Miss, did you mean for the 8 or 9?
Where? Right here?
No, on the partner.
99?
Yeah.
99? Yeah, 99. Because we're looking for the 99th term.
He's saying your A looks like
Your
a
A looks like a 9.
Oh.
294.
What was it?
294.
294. And then last thing I need to do.
Add 2.
Yep, which would give me 296. So the 99th term is 296. And that's it. Woohoo!
Miss Dodson,
Hmm.
please,
You absolutely can.